Hi everyone, I'm Sang Kim. In this video, I would like to share how to do single factor experiments in a randomized block design. The output of this analysis is same as two-factor analysis without replications. Let me show you how to do it in Excel first. There are 25 observations and one treatment named as car. So there are 5 types of car and there is one block. There are 5 rows. And then finally, we get score data based on car type and block. In Excel, we need to change data form like this way, 5 by 5 matrix. Okay, so there's a way to do this analysis by Excel built-in tool. So click Data tab. On the right side, you can see Data Analysis Add-in Module. And then click ANOVA two-factor without replication. Click OK and choose input range. There is a label on first row and first column, so click labels here and choose one cell to see the output in this spreadsheet. Right, this is the output. And then let me show you how to do it in R. In R program, in order to generate this design, we can use blocks function. So you need to activate blocks design. Then by using blocks, and we can make this design. So treatment equals 5, and replicates equals 5, and blocks equals 5. So there are 25 rows in design. So the first 5 rows are related to block 1 and the last 5 rows are related to block 5. Also, we can see 5 by 5 matrix form. So the number, you can treat this number as like treatment alphabet. So like 4 is alphabet D, and number 3 equals alphabet C, right? So once you have score data, you can do this analysis by AOV function. So after doing analysis by AOV, you can make ANOVA table by summary function, right? So I want to show you how to make this ANOVA manually. Right, this is the formula for this analysis. So let's get means by for treatment and blocks. So we can use every if function, range from column B, comma, and select criteria, comma, and average range from score. Press F4, right? We need to fix row and columns here. And for rows, also we can use average function, range here from column C, comma, and criteria, comma, and average. Again, we need to fix rows and columns by pressing F4. Then total average, we can use average function. Right, for sum of a square, we can use this formula. So number of blocks, 5 multiplied by mean of A minus total average. Press F4 and square it. Okay, for block, number of treatments, so there are 5 types of treatment, so multiply by row 1 minus and total average and square it. Right. Let's calculate total sum of square and error sum of square. So total sum of square is yij minus total average. And error sum of square yij minus average of treatment. So lookup value here, comma, table array, press F4, comma 2, and first, and minus the block average. So lookup table array for block, press F4, comma 2, and first. And finally, we need to add total average here. Press F4. Close the form and square it. Right. We are ready to fill in ANOVA table. So total sum of square for treatment, sum of this one, and for block load, sum of this one, right? For SSE, sum of column F. Okay, total sum of square. And this total sum of square should be equal to sum of total elements, right, which is same. So degrees of freedom for treatments is number of types, number of treatment, I mean 5 minus 1. And for block load, number of blocks, 5 minus 1. And in terms of error, degrees of freedom of error, 5 minus 1 multiplied by 5 minus 1. And total, degrees of freedom for total should be sum of all elements. Okay. And this is also same as total number of observations, minus 1. So mean square SS over degrees of freedom. The F value, so MS of treatments over MS of error. And for block, MS block over MSE. Right. Then we can calculate p-value. So from F distribution, P value is actually right side, right? So 1 minus F dot dist X value, comma, degrees of freedom here, comma, and second degrees of freedom from error, right? And true, because we need to use cumulative. Right. For p-value of block load, same logic, 1 minus F dot dist F value, comma, degrees of freedom from block, comma, degrees of freedom from error, and true. Right. So as you can see, the car p-value is lower than 5% significance level, but block load p-value is higher than 5%. Right, let's calculate F critical value. So we can use F dot INB probability as 0.95 because we consider 5% significance level, comma, and degrees of freedom from here, comma, and degrees of freedom from error. Right. f.imb degrees of freedom from block, comma, and from degrees of freedom from error here. Right. So only f value related to car, which is treatment, is larger than f critical value. So it means that only treatment is significant, considering 5% significance level. Okay? So we can say that in this model, there is no block impact, significant block, but car, which is treatment, is statistically significant. So there is different mean difference among types of car. That's it for today. I hope it was useful for you to understand single factor experiments in a randomized block design. Please click like and subscribe if it was useful for you to understand it. Thank you.